Dear students, welcome back to Aditya Tutorials. I am Rahul. Now in this video, I am going to extend the knowledge about the relative lowering of vapor pressure. So in my previous video, I was explained about what is a relative lowering of vapor pressure. And in that, I was explained that if there is a partial pressure of pure solvent A, then after adding certain solute, particularly a non-volatile solute, to a solvent which having a vapor pressure of P naught A, it becomes P of A. So in this case, this is the vapor pressure of solution and this is vapor pressure of pure solvent. It is a solution and it is solvent. In the solution we have non-volatile solute in it, and this is known as lowered vapor pressure. Initially the solvent having the vapor pressure of P naught A, but later when you add a solute, the vapor pressure reduces to P of A. It means that the vapor pressure of the pure solvent is always greater than the solution. This is known as lowering of vapor pressure. And how much it is lowered, that should be compared with the initial or the purest form of the solvent, that is P naught A. This term itself called as the relative lowering of vapor pressure. And this relative lowering of vapor pressure depends upon the mole fraction of solute. Mole fraction of solute. Up to this was discussed. Okay. Now let's move to the next part here. So we have to talk about the mole fraction now. That is Xi B is a mole fraction of solute. So I will write here, this is Xi B. This is a mole fraction of solute in the solution. Now it is given by number of moles of solute B divided by total number of moles in a solution. That is number of moles of solute plus number of moles of solvent, that is A here taken, where Na and Nb, I just write here Na and Nb are, the first one is Na means it is the moles of solvent, whereas Nb moles of solute. Now number of moles can be calculated. For example, if I have here number of moles of solvent is equal to given weight, that is Wa, given weight it is, and that should be divided by molecular weight of the solvent. Similarly, when I want to calculate the number of moles of B is equal to given weight, that is Wb, that should be divided by molecular weight of the solute B. For a dilute solution, for an instant, we have to conclude few things here. For dilute solutions, the number of moles of the solute is negligible when compared to the number of moles of the solvent. That is a number of moles of A plus number of moles of B. This is a term, the denominator term is comparing, means the number of moles of solvent is more as compared to number of moles of solute. Obviously यहाँ पे solute का quantity जो रहेगा बहुत ही कम रहेगा as compared to solvent. Okay, तो इसी वजह से जब हम sum up करेंगे दोनों number of moles, तो इसमें small portion रहेगा solute का. Number of moles of solute is very small portion, therefore यहाँ पे कोई भी वैल्यू में बहुत बड़ा अंतर नहीं होगा. तो इसी वजह से हम क्या करेंगे, यहाँ पे नंबर ऑफ मोल्स ऑफ बी जो है, जो डिनोमिनेटर में हम यहाँ पे यूज कर रहे हैं, उसको नेग्लेक्ट करेंगे और लिखेंगे यहाँ पे एन ऑफ ई, नंबर ऑफ मोल्स ऑफ ई. ठीक है, तो चलो अब नेक्स्ट हम सॉल्व करेंगे. वी हैव टू टेक दिस मोल फ्रैक्शन ऑफ B is equal to number of moles of B divided by number of moles of A. we eliminated this term, okay, because it is very small as compared to here. Okay, now whatever these two values are there, the calculation of number of moles if there is a given weight and molecular mass is there, that we can write here. This is equal to, it is for the number of moles of solute, here it is, that is WB divided by MB divided by, next here we have WA divided by MA. Okay, after simplifying we get here WB by MB, and that should be multiplied by, so denominator of denominator become numerator, therefore it becomes MA divided by, here it becomes WA. Okay students, now take, this is equation number 2, and I will take the first one, this is as equation number 1. Now I compare these two equations, then I am going to write here P naught A, the vapor pressure of pure solvent minus vapor pressure of the solution, divided by vapor pressure of pure solvent, that is equal to, mole fraction of B is there, instead of B I am going to write this value, that is WB by MB into MA divided by WA. Now I want here MB, that is MB is equal to, the value will be here WB into MA, and that should be divided by WA, and this entire term will be moved to the denominator here, that is P naught A minus P of A divided by, here it becomes P naught A. Okay, if we know the WB, that is a given mass of the, or given weight of the solute, given weight of the solvent, molecular mass of the solvent, then we can able to find out the relative lowering of vapor pressure experimentally, and by that we can able to calculate molecular mass of the solute. This is molecular mass of solute. Molecular mass of solute. Hope you understood this. If you understood this, let's move to the problem. We will solve one problem to clear the concept. Okay, here is a problem. We have to take a container. Okay, in this container we have to take the solute and solvent. The first, vapor pressure of the benzene we have to consider here. So first in this we have a solvent, that is benzene. Benzene we have. So this benzene containing a 50 gram of solute. In this we have certain solute, that is around 50 gram. Okay, I will take it's a 0.5 gram. Okay, 0.5 gram of solute. 0.5 gram of solute. So the mass of the benzene it is taken is around 39.0 grams. Okay, and one thing is that benzene means P naught of C6H6. This indicates that the benzene in its purest form have a vapor pressure of around 0.850 bar. This is the vapor pressure of the benzene in its purest form. Then when you add a 0.5 gram of solute to a benzene, that is 39 gram of benzene, the vapor pressure of the benzene, or you can say here vapor pressure of the entire solution, is changed. Its value is, it is the P value, vapor pressure of solution, that is equal to 0.845. You can observe here this is 0.850 and here it is 0.845 bars. A small change is occurred. The small change is decreased here. The vapor pressure of the solution is decreased as compared to pure form of benzene vapor pressure. Okay. Now these are the given things. By that you have to calculate molecular mass of the solid. That is MB we have to calculate. That is equal to big question mark. So how to solve this? The first of all we know the formula. That is the one of the important formula, that is P naught. Here I can write C6H6 minus P of C6H6 solution, because it contains certain amount of solute. That should be divided by P naught C6H6, that is equal to a mole fraction. The mole fraction or the other terms, that is WB divided by MB multiplied by mass of the solvent, that is a molecular mass of the solvent it is, and given weight of the solvent. Okay. After that we have to fill up all the values whatever it is there. The first P naught of benzene, that is here we have, that is 0.850 and that should be minus by 0.845 and that should be divided by 0.850, that is equal to, here it is the weight of the solute, WB is the weight of the solute and it is given, that is 0.5 grams and that should be multiplied by the molecular mass of the benzene. Here I not mentioned it is, you can take it C6H6 is equal to 6 into 12. 6 is the 6 carbons, 12 is the mass of each carbon atom, that should be added with the 6 into 1, that is the 6 hydrogens and the mass of the hydrogen is 1 and we get here 78 grams per mole. Okay, now I get here the 78 grams divided by MB, that we have to calculate. This is not given and now it is multiplied by 79 because it is a weight of the solvent given, that is 39 grams. Okay, after that we get here the first numerator, it becomes 0.005 and that should be divided by 0.85, that is equal to, here we have 0.5 as it is into 78 and that should be divided by MB and finally it should be multiplied by 39. So this implies some solutions here I will do, that is MB is equal to, just I take MB on this side, it becomes here 0.5 78 into this denominator will move other side and become a numerator and it becomes here 0.85, that should be divided by, here whatever the term is, 39 is there, 39, that should be multiplied by this quantity. Here it is a numerator but on the other side it becomes denominator, that is 0.005 and later we get here, that is 170 grams per mole. So this is the molecular mass of the solute. This is molecular mass of the solute. Hope you understood this problem. So we'll see one more problem to clear the concept. Here is a container and in this container I taken the solvent and solute and we have to calculate the mass of non-volatile solute, that is MB as usual. MB we have to calculate, that should be a big question mark over here. And here what we have, we have to calculate the mass of the solute and the given things are here, that is there is a solution and that solution is made by, in the octane, that is 114 gram of octane is taken, octane, and this is a solvent, you remember, this is a solvent. Okay, now in this solvent you added a certain amount of solute. the solute, the molecular mass. So, okay, we have. Okay, now here is a question given. Calculate the mass of non-volatile solute. Mass you have to calculate means it should be WB is required. That is a question mark here. Because molecular mass is given, that is MB of the solute, that is 40 grams. And dissolved in the mass of the solvent, that is WA, it is mass of the solvent, it is 114 grams. And here WMA, we want here MA from the octane. The octane, the molecular formula is given by C8H18, and we get here 8 into 12 plus 18 into 1, that is equal to, we get here 114 grams. Okay, so molecular mass and given mass is same in this case. This is good. For the calculation, it's going to help us. And we have formula here, P naught of the A minus P divided by P naught of A. Okay, that is equal to mole fraction. Mole fraction can be expressed as WB divided by MB into that is MA divided by WA. So in this case, we have to find out the WA, and therefore I am going to write before. Here they are mentioning that the vapor pressure is reduced to 80%. Before it was 100%, and when you add a solute, a certain amount of solute, WB gram of solute in around 114 gram of octane, the vapor pressure reduces to 80%. So okay, तो यहाँ पे जो P naught value रहेगा, that should be 100, and whatever the pressure reduced, that should be around 80 divided by 100, that is equal to WB as it is, because we have to calculate that. MB it is given, that is 40 grams, that should be multiplied by, that is mass of the solvent 114. This is, both the values are same, this is to get cancelled. And come to the next here, the 100 minus 80 is 20 divided by 100, that is equal to WB divided by 40. So here we get WB is equal to, we get to 1 divided by 5, or I think I will get here 40 divided by 5, right? So we get finally at here, we get 8 grams of solute is taken. Okay, when you add 8 gram of solute to 114 gram of octane, then the vapor pressure reduces to around 80%. Okay student, hope this concept you understood correctly. We'll see one more problem that will be helpful us to understand the concept again. Okay students, there are two situations. So take a container, and in this container I am going to take 30 gram of non-volatile, solute. Okay, and the solvent is water. The solvent is H2O, that is water. And the solvent is taken, that should be around 90 grams of water. That should be a solvent here. Okay. After that, the vapor pressure of this solution. Okay. Vapor pressure, this should be a case 1. Okay. This is a case 1. In this, the vapor pressure that is given here around 2.8 kilopascal at 298 Kelvin. Same container you have to take, and in that you have to add around 18 gram of water, H2O, and this should be a second case 2. So initially in the first case, the vapor pressure we have 2.8 kilopascal, but when you add 18 gram of water again, you make the solution more dilute, and by that here the vapor pressure changes, should be increased, right? Because the solvent is increasing here. So therefore the vapor pressure of the entire solution in the case 2 becomes 2.9 kilopascal at 298 Kelvin. And in this case we have to find out the molecular mass of the solute. That should be a big question mark for us. Okay, it is very interesting question. We have to make two equations separately and we have to calculate. The first move to the first part with a formula. We know the formula, that is P naught of A minus P A divided by P naught of A, and that is equal to WB MB into MA divided by WA. Okay, in this, whatever the given contents are there, we have to put up in this. The first case we have here, that is a P naught A as it is minus P of A, it is given. The vapor pressure of solution is 2.8 divided by P naught A as it is, and that is equal to WB, it is given, that is 30 grams, it is added, and that should be divided by MB because we have to calculate the MB here. Next, that should be multiplied by 18, that is the molecular mass of the water is 18. Here it is, molecular mass of 18, molecular mass of water is 18 divided by weight of the water taken, that should be 90 grams. And finally we get the simplified equation is P naught A minus P, okay, sorry, it should be 2.8 divided by P naught of A, that is equal to 6 divided by, because it get cancelled, 3 ones are and 3 threes are, and it becomes 3 6 are 18, right? It is 6 divided by MB. This is taken as equation number 1. The same thing we're going to calculate for the second case. In the second case, whatever we have, that is 18 gram of water is added to, already there is a 90 gram of water is there, in that you are added 18 gram of water, by that the vapor pressure should be increased here, and by that we get equation, that is a P naught of A minus 2.9, that is the P of A, that is in the second case, divided by P naught of A, that is equal to, directly I going to write here 30, because that is 30 gram of non-volatile solute, that is remains constant, divided by MB multiplied by, here I get, that is 18. But what about the mass of the solvent? Initially it was a 90 gram, in that you are adding 18 gram, means it becomes 108 grams, 108 grams. After simplification, we get equation, that is a P naught A minus 2.9 divided by P naught A, that is equal to, it get cancelled, and we get here, that is 5 divided by MB. This is taken as equation number 2. These are the two equations we got. Now what we have to do, we have to divide these two equations. That is, equation 1 is divided by equation 2. This equation divided by equation 2. And we get here, that is a P naught A minus 2.8 divided by P naught of A, the whole divided by, we have this term, that is a P naught A minus 2.9 divided by P naught A. This is equal to, that is 6, this term first I going to write here, 6 divided by MB divided by, we have 5 divided by MB. Okay students, after that these two terms get cancelled. Along with that, these two terms get cancelled, and we get here, cross multiply these, or simplify one step more, that I get here, that is P naught A minus 2.8 divided by P naught A minus 2.9, that is equal to 6 divided by 5. Cross multiply these, and we get here, this implies 5 into this term, that is a P naught A minus 2.8 is equal to, multiply 6 with this term, denominator, 6 into P naught A minus 2.9, and at the end I get here, by solving this all, it is a lengthy process, and I get direct answer here. P naught A is equal to, that is 3.4 kilopascal. This is the value of the vapor pressure. Okay students, this is the purest form of, that is water vapor pressure in the purest form. Substituting this value in the equation number 1 we get here. This is the equation number 1. In the beginning we have taken that is 3.4 minus 2.8 divided by 3.4, and that is equal to 6 divided by MB. And this implies here that is MB is equal to we have here 6.0 into 3.4 divided by we have here 0.6, because when you subtract these two you will get 0.6, and the final answer is 34 grams per mole. This is the molecular mass of the solute dissolved in the given amount of water, students. Hope you understood this. In the next session we are going to discuss, that is the most important term, that is elevation of boiling point.